Okay, let's get started. It's right at the top of the hour. My name is Steve Thompson. I found out yesterday, actually I'm a Config Manager MVP and SQL Server MVP before that. I found out yesterday I'm no longer Config Manager MVP. It's now Enterprise Client Management. So sorry about that, slide's out of date. I work for Dell Services, both supporting Dell internal and also external clients as well. One of the things that would happen when I published the agenda for this, I was originally going to do 60 minutes just based on queries, and I could easily do that. But what I've found and what I learned as things developed, found different ways to optimize and tune Configuration Manager databases. So I thought that was important to share with you. So what we're going to talk about here is basically a two-part session. Our first part is going to be basically solving common questions with queries, things that people run into all the time. I'm going to delve into understanding the query process because in order to understand how you tune databases and some of the concepts I'm going to introduce, I think it's important to understand some of the more technical concepts of the process itself. I'm going to basically show you how to identify common performance issues, delving into statistics and indexes, and also what I like to call taming SQL performance issues. And part of that will be showing you an SQL audit script that we've developed using PowerShell and SQL queries, and also implementing a custom database performance solution. And I ask you, please hold questions to the end, and I'll attempt to allocate 5 or 10 minutes for questions, okay? So advanced query techniques, let's dive in. I've got 3 sets of scenario-based query questions, if you will, or solutions. I'm going to also discuss briefly the methodology of locating information, which is sometimes one of the more challenging aspects. You know what you want to get, but where is it, right? There's seems like 1,000 views. And then also I'm going to be talking about how to enhance queries. So the first scenario, how do I get a list of all collections? And it's funny because this came up in part because if you're familiar with the new incremental update option in Configuration Manager, according to a white KB article I read, or perhaps a white paper, there's a limit of about 250. So in other words, if you go beyond that, you can start running into performance issues. So do you have any idea how many are set that way? I didn't, so I wrote a query to find out, and I'm going to walk through that, and also be covering kind of core concepts as well. Interesting on the last bullet point there, the reference. I've included a link there. If you haven't seen this, the Configuration Manager 2007 views, definitely download it if you're interested in creating your own custom queries. There's a lot of overlap between what existed in 2007 and 2012. However, there's some new things in 2012 that aren't in that, but it'll get you a major part of the way there. I also talked to the documentation team while I was here this week. They promised us that there will be the 2012 views released. I was hoping to give you some kind of update. But all I can tell you at this point is they tell me it's a high priority and they're putting resources on it. So the first set, how do I get a list of collections? What I want to first show you, and I've already installed the Configuration Manager 2007 views. This happens to be the Visio. There's also an Excel diagram as well. And if you notice on the bottom of this are tabs. I'm selected the collection tab because I want to learn more about the collections. And notice we have 2 views immediately in the center. One is the V collection and V full collection membership. I'll be working with both of these views, but it's helpful to have a roadmap of where this information lives within the database, and that's essentially what this is. Within V collection, the collection ID, the one that's highlighted blue, is actually the primary key for the table, and that's useful to know because that's used to join to other tables. And if we take a look at the full collection membership view, you'll notice that there are 2 that are bold, collection ID and resource ID. Those are, the 2 of them make up a composite primary key, and so they also join to other things. So with that in mind, let's look at the queries. Also, just to tell you my environment, I've got a standard Dell laptop here. I've got extracted a sample, the test site, if you will, that we have has about 1,100 clients on it, and I restored a copy to my laptop. So I'm working with real Configuration Manager data, running SQL Server 2012. That's about it. So if you're not, and I'm just going to walk through this. It's going to start off a little basic, and then we're going to go into the more advanced stuff. So if you've been using SQL, hopefully it's not too boring for you. The first part, when we use the use statement and go, basically allows me to execute and switch the context to the actual database we want to use. So the first example, I'm going to show you answer the question, how many collections do I have? As we go through this, I'm also going to show you some tips and tricks that I've kind of learned. One of them is Control E. If you select it and execute it, it will just execute the selected text. The other thing you can do is highlight it and then click the execute button on the top. So I know I have 257 collections at this site. If I want to get what I call a raw list, I do a select star from the collection, click execute, and there's my results. So I can scroll over. And it took a little bit doing because I was trying to figure out where the incremental update is because that wasn't documented. So I found out it was refresh type. And then as you can see, there's numbers, 4, 6, such, and so on. And what I ended up doing is just going back to referencing a collection, a known collection, and figuring out what it is that way. So as you can see, one of the things that I always end up doing, and I suspect you do as well, is I tend to build queries in kind of an incremental process, right? Start off with sampling the data perhaps, and I'll show you some sampling techniques in the next demo, and then start building those things out. So what we're doing here is this is a case statement where I've translated those values. I found out 1 is no scheduled update, 2 is a full scheduled update, incremental only, incremental and full. So what this means is now this translates into more human readable text. So if I execute this, you see now I have my refresh type in clearly readable manner. And any of these queries, by the way, I should have stated in the beginning, we're dealing with straight SQL, not WQL. So those of you who have written WQL queries that are used in the console, I'm not going to go there for this. This is purely SQL. But the advantage of doing it in SQL is we could translate any of these into a report. Okay. And they also tend to be a lot faster because WQL has to go through the provider. So now the next step is, okay, great, I've got a list, but how do I know how many incremental are set? The next one I'm going to do an aggregate, which you have to do a group by. We do a select case again, but notice what I'm doing is grouping by the refresh type. If I run this, you'll see that now I have a summary and totals for each of the different types. Can everybody see that okay? I can zoom in. Okay. Then finally, the other thing that I like to show is this new, well, I don't know about new, but it's called rollup, and it gives me the ability to add a total. Obviously, I could bring this into a report and then do a summary based on the information, but I can also get a total directly within the query by using the with rollup. The other thing I wanted to show you, another little tip and trick, if you've ever looked at the views, there are literally, it seems like 1,000 of them. There's this little filter option. You can see me selecting the toolbar, and this is helpful because if I wanted to just view the views that happen to have the name collection in them, I can type collection, click OK, and now I have a filtered view. And if I expand this view, I only see the views that have collection in the name. It's a lot more manageable, okay, as opposed to seeing the full list and trying to figure out where things are. To clear the view, I simply clear the filter, excuse me. I simply select the filter option, clear out the collection, click OK, and now my views are back. So for the next scenario, and I'm going to cover basically 2 join types, inner join and left outer. Those are probably the ones used about 95% of the time. There are other joins, but I wanted to really kind of delve into the ones that are quite commonly used. And this actually came off of my IT forum list. How do I get a list of all servers that have any version of SQL Server installed? And so I went through the exercise of creating the query for the person that asked it, published it, and said, this might be kind of interesting to walk through this as a scenario, just to kind of get the feeling of, how do you do this? How do you solve this problem? And the second one that usually comes up as well is how do I limit by collection? And again, think reporting where you have a nice query, but you want to limit it by a particular collection. Okay, so fairly common things. And I've also listed the core concepts of things that we're going to go through. So an inner join is give me all of the matching pieces of information. In this case, I'm joining system to workstation, and an inner join will bring back everything that matches in that intersection. And there's a sample query on the bottom as well. Typically, it will say inner join. And also notice I'm using what's called table or view aliasing as well. It makes it a lot easier to read. So let's go right into the demo. The first step that I like to show is what I call data profiling. Yes, you can do a select list. Like I happen to know that the service names are stored in a view called VGS service. Now, I could do a list, but it's going to be literally maybe tens of thousands of rows, 100,000 rows in a very large site. So I like to do something called data profiling, where I'll do a select top 10 or a select top 100. So if I select this, one, it runs very quickly. I get up to 100 rows back, and it basically it gives me what I need to know, just in terms of looking at this information and see, okay, what do I have here? I happen to know the service names for SQL Server start with MS SQL, and I'm querying on names, so here's the name. And I like to just take a look at what kind of data am I sampling, what does it look like? So I have a pretty good idea now of what we're dealing with. I can see the various display names. And now I also need to reference, because remember, it's how many servers have SQL Server. I'm going to select the top 10 where the caption is like server. Again, profiling and sampling to make sure that the data looks correct. You can see I have 4 rows coming back that are running Server 2008 R2 Enterprise. So now the idea is, let's put that together and give us information that where those two match. So here's 2 inner joins. Basically, I'm pulling this information from GS Computer System. I'm joining on the service, and I'm joining on operating system, again, back to the resource ID, because that's a primary key field. The primary key field is a unique identifier. Always try to use the primary key field and not things like name. It's going to be a lot more efficient and a lot faster. So we select this. Let's run it, see what we get. Okay, we're getting some data back, but notice there's some duplicates in there. Why? Because when we ran the services, we have multiple service names. In fact, SQL Server allows you to install more than one instance, so you could have 3, 4, 5 instances of SQL Server. Well, now I've got some core information, but let's refine it a little bit. Plus, I'm also getting workstations back in this mix as well. So in the next step, I'm going to basically isolate it, where I'm going to bring in back just server and MSQL. And notice now I've got it reduced to 2. So by the select distinct operator, and I could have used group by, but I just want to show you different syntax, allows us to basically take all the duplicates and reduce them to just the information we're looking for. And these scripts, by the way, will all be published on my blog. There's a link to that at the end, so you'll be able to download these and try them out, so you can build your own. The next thing I want to show you is, again, this goes back to the question, how do I limit by collection? One of the things that I often do, especially if I'm building queries for reports or I'm troubleshooting queries, is sometimes it's nice to put in various parameters, right? So I can change them on the fly. I can see what different results are based on different collection names. This is a declaration where I'm creating a variable, if you will, in a SQL Server. This second collection, or second query, or second statement in the batch here is selecting, give me the collection ID where the name equals config manager site systems. I happen to know that the servers I want are in this collection. And then the print operator gives me feedback. Okay, in this case, I want to know what's the collection ID. And I can run this in stages as well. So let's select everything from the declare down to the print. And if you notice the message on the bottom, it gives me the collection ID back. So now that I have that information, I know I can substitute the collection ID, see this parameter on the where statement. What that allows me to do is say, okay, substitute whatever's being passed to it, and then the query will basically resolve that and run. So if I select the entire batch, execute that, you'll see now we get the information back based on feedback. Now this could easily be translated into a report query. So you can put this into SSRS, have a parameter-driven query to give it by collection. Now the third set that I want to talk about is a little bit more advanced, where we were dealing with how do I get a list of all computers that have not reported hardware inventory. And that might be interesting to track down, because perhaps there's issues in the environment. You need to know why things are the way they are. Also, how do I get a list of computers that have not installed Adobe Shockwave Player? And this actually was a query I pulled out of the TechNet forum and then kind of refined it, made it a little easier to read. So the core concepts we're going to discover here at left join, the not in subquery. I'm going to be talking briefly about schemas and also how to create a view. So a left join is, if you think back to that other slide I showed you that had essentially the intersection, a left outer join, and it can be written either way, left join is fine or left outer join, will basically encompass everything on the left-hand side. That's the way you think of it. So it's the left. And so it'll give us not only the intersection, but whatever is on the left side. So in this case, if I design my query correctly, I'll get everything from the system view, which includes matched and unmatched data. Okay, does that make sense? Because what I want to do is say, okay, how many have not reported a last hardware scan date? So if you look at the sample view there, what we're looking at is show me everything where we're doing a left join on the system resource ID where it matches or does not match the resource ID from workstation status. I'll show you how that works. So the first query I have here, and I deliberately joined to the VR system, which is discovery data, so I know there's going to be a lot of unmatched data here, which may or may not be an issue, but again, this is more for demo purposes, okay? So what I'm doing is joining on workstation status. I'm bringing back, again, the resource IDs, doing a match on those. So if I run this, we'll see we get a list of all of the machines. In fact, notice I've got 1,278 rows being returned. You can see that in the lower right. And it also has a mix of machines that have returned hardware scan and those that have not. And notice a couple other techniques I'm doing here is I'm renaming the fields that are being returned so you can put them into more readable names. And there's a couple of examples. I'm renaming the netbios underscore name 0 as machine name, and also a way of showing you how to insert spaces into the column name as well. So to return, now my question again was how do I return them where the last hardware scan date is not there? Well, if you notice in the results we're getting nulls, and nulls are kind of a special case. We have to use is null to basically call those out, or is not null to return those that are not null. So what we're going to do is add this where statement, select again and run it. And now I'm getting all the ones that are null. Notice I've got 168 rows returned. So these are the machines now that have not returned any hardware scan information, which again may or may not be an issue. So to answer the other question is how do I get a list of all computers that have not installed Adobe Shockwave? Just open this up. A couple of key concepts I want to discuss here, and I will zoom in on this one. We have what's called an inner join, which is this part here. And the outer query is running and it's giving information. You notice the not in part here? So the query is running and it's saying, give me all of the machines where the resource ID is not in this. And it may seem, actually I should have selected, notice this where is included in here as well. Sorry about that. So what it's doing is, you're kind of returning the positive. Bring back all the machines that have Adobe Shockwave installed, and then the second part of the query that runs says, okay, give me all the machines that are not in the other query, right? So what we're doing is kind of isolating out the ones that have the information and just returning those that do not. The other thing that I want to show you is in terms of readability, and I see a lot of queries, I write a lot of queries, I really like using indentation because things line up properly. It's a lot easier to read than if everything, for example, is all lined up on the left-hand margin. And therefore, it's like take the time to like design it, make it look right. It's a lot easier to not only troubleshoot sometimes, but for other people to pick up your code and read it. So we can select this and run it. Hopefully I didn't change it too much. And notice now I'm getting the machines back that do not have Adobe Shockwave. I've got 1,074. So for instance, if I needed to target those in a collection, we could probably build a collection based on that information. The next step I want to talk about is, okay, now we start creating these custom views, custom queries that we're going to use in our reports. What's a good way to do that? Well, Microsoft recommends that you do not change the internal structure of configuration manager databases. So one of the ways that you can do this and do it in kind of a nice, pleasant way without causing any harm is to use the concept of schemas. And what a schema is a secureable object. And if you take a look on the left here, I've got within every database is a grouping called schemas, and that's under the security role. And schemas, and if we go down here and take a look, you'll notice that there are some already in here from Configuration Manager, often used in reporting, by the way. So what we can do is name it whatever we want. In this case, for honor of MMS 2013, I'm creating a new schema. So I just ran it. I like to script things because they're easy to reproduce. And if I do a refresh here, see now I have a new schema. Now, I have the ability to put security on this object as well. So in other words, I could isolate it to maybe just the report users Active Directory group. So it gives us additional ability to secure this. Plus, any objects I create in the database will be using that schema, not the default DBO schema. So here's a view that, in fact, if you notice, this is the query we ran before, which brought us back all the information where machines are not returning hardware information. And notice I have a create view, and I prefix it with the name of the schema. So if I select this, run it, creates it successfully. Now to run it, notice all I have to do is do a select star from, and then reference it by the schema name, execute. One of the things you cannot do in a view is put an order by clause, but you can always add the order by after. So for instance, if I want to order by machine name, I can run it. Now it's ordered by machine name. I've got same as before, 168 rows. So query process. And this takes, like, let's say we're creating queries now. We're starting to run into some issues, okay? We've run into some performance issues. And have any of you had queries that either ran a very long time or maybe didn't run at all? I've seen a few heads nod. Familiar story? Okay, hopefully we can help you with this. So what I like to do is I like to take things apart. I guess I'm a little bit of a tinker. I like to know how things work, right? So understand that, keep that in the back of your mind as I go through these next few slides. I like to understand the underlying issues, and then finally, once I understand them, then take a look at how we can remediate those. How can we fix them, right? So to understand the query process, SQL Server is really broken into two parts conceptually. There's a relational engine on the top of the line and the database engine below the line. The relational part is basically, think of it abstract. It's all the stuff that happens before the query actually goes and runs on the database side. So there's a lot of things involved there. But I want to walk through the steps. I've consolidated a couple of them just for brevity and just so we can focus on the things that are important to understand for fixing performance issues. The first is SQL statement, much like the ones I showed you today. Select star from foo. And the second part is the parsing and binding, and these are often broken out into two separate steps in the documentation, but for this example, I'm going to combine them. The parsing says, okay, is it SQL syntactically correct? Is it written properly? Does it look okay? If so, then it goes to the binding stage. The binding stage says, okay, all of these columns have meaning. They map to tables through the views, and they have either data types, ints, columns, varchar, whatever. So the binding says, okay, take this information, bind it, so now I know what kind of data types I'm returning. So if you ever see those data type error, that's happening in the binding stage. So assuming that that's all good, it goes down to the query optimization stage, and this is where things start to get interesting, to me anyway. The statistics get involved at this stage, and statistics are, and we're going to be delving into more of those, think of them as the ability to quickly tell where do I go, what indexes do I use to get the best performance from my query. So the optimizer runs through a series of analysis. It looks at dozens, perhaps tens of dozens of plans, and it generates cost. And it says, okay, I'm going to take the one that costs the least. Just like going to the supermarket. You look at different brands, you go, okay, I like that one because it's the same thing, but it costs less, right? We all take the one that costs less. So that once it figures out the plan, it passes the plan onto the storage engine, and then now we're into the query execution phase. Query execution phase takes the plan the optimizer came up with, says, okay, do I have any indexes available for me to use? And the indexes are used where it goes out and actually pulls the data from the disks, okay? Finally, the query results come back, and obviously I've glossed over a few things in here, but for sake of argument, there is an execution plan that once it runs and it gets stored in memory, that will get used over and over again if it can. But then gradually over time, that execution plan will get aged out as other things come in. The other thing you need to know is below the line, there's also a data caching going on here too. So as it feeds information from the database back to the report, it'll store the data results as well. So the idea being that information will be cached in both places, and that if it picks the right plan, it'll be really, really fast. If it picks the wrong plan, it could take a long time. So statistics, and I kind of went over a little bit of this, but they may indeed improve the query optimization plans. In fact, sometimes the results can be quite impressive when the right one is chosen. It also can be quite awful when the wrong one is chosen. And as I mentioned, the plan with the least cost wins. How are they created? They're created, in fact, every database has an auto statistics selection for a database option. Normally that's on by default. You can go in and check that. It's part of the database properties. And so there are standard statistics that are enabled for each table. But as you start running queries, they're automatically created. And a statistic contains about 200 different data sampling points within the table. So statistics know how many rows exist in the table. And in fact, it's put in something called a histogram, where it basically takes data sampling and reference points so it knows what to do. And this is an example. Just by running this simple query, it created 2 additional statistics on this table. And you can go in and look. If I have time, I'll show you, but I want to make sure you just understand the concept of where these things come from. How are they maintained? Somewhat automagically. But they get created and supposedly updated when that query, that same query I showed you in the last slide were run a month from now, it should update those statistics. And I say should because it may or may not, quite frankly. And so statistics may become stale over time. In fact, they do become stale over time. I've seen it, and I can prove it. How do you know if they're stale? And I'm giving you a couple of examples, actually three different functions that you can get that information. One is the DBCC, show statistics. Stat state is another one. And something very interesting called DMV, or dynamic management views. I use these a lot in my SQL audit script, which I'm going to show you in a little while. And these are all prefixed by the sys. They're built in. They're part of the core product. In every database, you can see the dynamic management views. And I use them a lot now because they're very powerful. They give you some core information about the database that it's hard to get otherwise. How to update? Update statistics, or exec SP update stats is one way. And I'm going to show you a more efficient way to do it in just a few minutes. When to update? Well, that's always an interesting question. When to update? Some people say, well, update it daily. Well, it turns out there's another issue with that, which I'll talk about in a minute. I like weekly, but it all depends, right? It depends on how active the database is, because statistics get out of date for a couple of reasons, primarily because there's data changes, right? You have updates, inserts, deletes. But if you had a static read-only database that's just there for reporting and never ever changes, there's no reason to update them, right? Because it'll always reference the same plans. The data will always look the same. So talk about indexes now. As I mentioned before, indexes are used by the storage engine. It's important to know that there are 2 primary index types. One is clustered and the other is non-clustered. Clustered means that there's only one clustered index per table allowed, and that's because the clustered index stores the actual table data in the index. Okay? So what that means is as you have data growing, that actually those indexes contain the data items themselves. So sometimes if you write queries that just go after the indexes, the primary key fields, they can be very, very fast and very efficient because the database doesn't actually have to go and get the data back from disk. It's able to pull it out of memory in many cases. Now, non-clustered indexes, you can have more than one, and they're quite commonly used to help speed up the performance because they're pointers referencing other parts of the data. And indexes are stored, technically, just so you know, they're called pages and extents. Each data page is 8K in size, and an extent is 8 pages of data. So it's 64K total per index or per data element. Now, page splits, you need to know about these because indexes, when everything's first created, it's wonderful. They're in perfect order here. Just a brief screenshot. This is one of our tables, system discovery data. You'll see I've highlighted the clustered index, and the rest of those are non-clustered indexes, which are quite often used for joining other tables and views. Now, page splits, let's talk about these. Because in a perfect world, indexes should always be fine. You never have to reorganize them or anything like that. And this is what either a brand new database, brand new index looks like. All the pages are nice and contiguous and in order. And what happens over time is as data gets inserted into the database, the index fills up. And once it gets to a certain point, it can't hold anymore. It actually has to split, has to stop, create another index page, move the data over there. So it's kind of an expensive operation. It happens very quickly, but if you can imagine, over time, indexes tend to sort of degrade, if you will. And if you look at the lower graphic, that's probably what one looks like after all these inserts, updates, deletes take place. You've got empty pages, you've got full pages, and so it takes longer and longer for the server to get the data off the disk. So to understand index optimization, there's a lot of things going on in the background, but to summarize, if your indexes are lightly fragmented, and lightly means perhaps 10 to 30% or 10 to 40%, depending on where you set that parameter, it might be more efficient to reorganize them. In other words, let's just move things around and kind of like make them look pretty again, right? If they're really, really hideous, like that slide I showed you where it's all kind of broken up, that's when you want to do a rebuild. And a rebuild basically drops the index and creates a brand new one. It's actually faster than trying to fix something that's really messed up, okay? And then finally, the other thing we need to know about is called the fill factor. When you create or rebuild an index, you have the ability to set a threshold. Say, okay, only store up to 80% on an index page. So that way I'm allowing a little room for growth so they won't get split as often. Where you put that fill factor, it really kind of depends because every database is different, every situation is different. So you have to kind of, you set it, make a guess, monitor it, right? How to update? We alter index is the statement that we use. And again, what's best? It really depends. And there's a lot of depends there. I'm sorry for that, but it's like there isn't just one answer, right? It's like you kind of take a best guess, best guesstimate, set it, and observe it. As I like to say, measure, choose, and monitor, right? Wash, rinse, and repeat. So what I wanted to talk about is, and this falls right into the audit because this information that I'm talking about is not, it's not readily exposed, right? I mean, how do you know if I ask you, okay, tell me how defragmented your indexes are, would you know, right? So what we've been working on is a technique that makes it easy to figure out where you are with your indexing, figure out where the fragmentation is, and write it in such a way that you don't have to be a master DBA to figure this stuff out. So as part of our onboarding of additional clients, we really decided that we needed one way to kind of detect what's going on out there, and I call it documentation because that's the way it started out. Document the current instance. Identify potential issues. Do we have potential database issues in terms of where things are? Are our statistics indexes out of date? Do we have database recovery mode set incorrectly? If you came to the Monday session, I talked about that on the reporting server database. And then finally, in order to make this thing work, we need to break it into two pieces. We wanted to collect the information, be able to combine it in an Excel workbook, and then also I wanted to make it extensible because I knew over time I'd either find things that need to be added or taken out, and I've already changed it a couple of times, adding additional information, collection information. So let's delve right in. Can everybody see this okay, by the way? Do I need to zoom in on? Okay, I'll take that as it looks fine. A couple of things here. This is the audit script that I was telling you about. And what it's doing is using the SQL Server PowerShell provider. And so, in fact, Greg Ramsey helped me write this. Give him credit for that. I had a lot of interesting scripts and things like that where I got this information, but what we were missing was the ability to be able to put this one script on a server. You do, in terms of permissions, you do need to have sysadmin rights in order to run this, just so you know. The only thing that you really have to vary are perhaps two, but the first is this variable here where, I've commented it, I like to put the things I need to change in the very beginning of the script. So and here we're running on the tempdb. On some servers, I have to switch it to other drives depending. And then the other thing that you may or may not have to change, this was written particularly to reference Configuration Manager 2012 databases because they all begin with CM underscore. I have run this on CM 2007. What you have to do is basically I just hard code the name of the database to this database name, and then it will run appropriately. I want to walk through this just from a real high level, but I will make these available so you can take a look at them, use them, and let me know what you think. Always looking for ways to improve it. I'll take the first example where we bring back the server properties. And notice this is a standard SQL statement. I could copy and paste this into Management Studio and run it. We prefix it with the invoke-SQL command-query. And so what this will do is run it against the database that we've selected in that step before. And then what I do is export these to a CSV where I give it a name and call it with a CSV file type. And I'm going to scroll down, and I've got all of these commented so you can see what they are. Database properties. I want to show you a couple of the variations that we had to figure out. So we have the first 16 of these are SQL Server specific, and then I delve into actually bring back specific information about my configuration manager instance. And notice I substitute the database name, and this is giving me specific file information in terms of the actual file sizes that are in use for configuration manager, which might be useful. And then finally, the statistics on the database. And then the other thing is that the index fragmentation query, and I just have to tell you, on a very large database like ours, one of our primary sites supports 70,000 clients, it can run a while. By a while, 15 minutes maybe. So just be aware of that, and I had to actually find out how to set the query timeout so it wouldn't time out on me. So just fire it up, and don't think it's broken, just give it time to finish, okay? So once that's complete, and by the way, I've also included, this is what it looks like. In fact, let me kick that off now and we'll let it run, and I'll continue to talk about the scripts. So I've got a tempdb set up, and notice what I'm going to do is just simply run the command file, which then launches the SQL PowerShell script. You go back to my note here. And then finally, the next piece is once you have all the CSV files, this is a fairly standard little script here, which takes all the CSV files and converts them into an Excel workbook. And it puts them together along with the tabs. It creates tabs that are named as the CSV file. So again, I'll let you take a look at this on your own time. But the magic happens here at not only with what's being processed, but we have this little routine which goes through and pulls all the CSV files and then puts them into an output, and it names them in a year, month, day format so that we can tell when they're run. Let's go back and look at our script. So what it does is it populates all the CSVs, and now to combine those, I run that little compile report script, run with PowerShell, and it doesn't take very long, but we should see another entry come up here. There. So if I open this up, you'll see it brings back the information about my computer. What I want to do is, and so you understand how it runs, and I'm going to show you actually, this came from our CAS, our content, our CIS server. I've changed the name of the server to protect it. But anyway, it's running Standard Enterprise Edition. It brings back the service pack information, version info about the server, along with particulars, so that way I can know exactly where my server is in terms of the current patch level, installation date, which is kind of interesting to know because what I've seen is I can correlate this sometimes to how old the statistics are, and also maybe perhaps how bad the indexes are. Configuration values, if you run an SP configure, that'll show you all of the database settings, in fact, in the advanced properties. So this is a useful one to know. I like to have this on hand, and just in case, if you ever had to do a database recovery, for example, you'll have all this information documented. So we go through these various pieces of information, database file names and paths. So this gives us exactly information about where the files are physically located, the actual size. Database properties. Remember, I had told you this is where you could easily look to see the recovery mode for any of your existing databases. Server and other detailed server information. What I'm going to do now is go over to the end. Oh yeah, SQL file log server space. This is another one that I'm thinking about other ways we can leverage this information to kind of monitor it over time to see how it grows and expands. I think there'll be a blog post coming up on that. CM file sizes, again, a little more detail about those. And then finally, index fragmentation. This was actually run off our central site. And again, we support about 170,000 clients. If you look at this column over here, the average fragmentation in percent, hopefully you can see that okay. I was somewhat surprised to see how fragmented this database was. And I also have to say that we had the index, site maintenance index task, rebuild task enabled, but for whatever reason on our site it wasn't running. I've gone back and forth with Microsoft on this. It may be a bug, I don't know, because they say they can't reproduce it. Yet I've had other people tell me that it doesn't work. So again, I'd like to get some feedback, after you run these tools. Tell me what's going on. Is it working for you? Great. If it isn't, let me know. And also, would like to see if it does indeed fix it. So this was actually a before. I want to show you the after. This is the same server. Let's scroll over to the end here. I've also, notice the fragmentation now. Looks a lot better, doesn't it, than 98% fragmented? And so I've set certain thresholds, and I rebuild it once a week. So it'll go out and intelligently picks out the ones that need to be reorganized or rebuilt, again, based on the parameters. And the other thing that's kind of interesting to note is this page count. I only want to rebuild indexes if they're over 1,500 pages. If they're below 1,500, in my opinion, that's the threshold. Don't do anything with them. It doesn't really make sense to reorganize because 1,500 pages is 1,500 times 64K. It's a small amount of data. I'm looking at the ones that are like in the gigabyte range here. So one of the things that's interesting to know is as you're debugging queries, one of the things that I like to do is use a couple of tools. And these tools come installed standard with SQL Server. They really will help identify performance issues. The first of these is Profiler. The second is Show Query Plan. Why would you use these tools? Show Query Plan is an interesting one, and it will give you a lot more information about what's going on in the background. It'll tell you, like, for instance, how many is it properly using the indexes? Are you doing table scans, which can be very costly? Is it doing clustered index seeks? And I've got a couple of references at the end of this slide deck where you can actually go out and find out more information about how to interpret these. It could almost be another session in and of itself. But I'm going to show you how to use them and why you'd want to use them. Is in particular Profiler I like using if I'm, in fact, I've done it before, taking apart some of the standard canned reports within Configuration Manager. If either I'm troubleshooting something or I want to see what kind of SQL is being run in the background, I fire up a Profiler trace, and it's much like a network trace, only it shows me all the SQL being sent against the database. So you can then capture it and then get the SQL out and then start either using it to customize it or make a report out of it. And then finally, and I'm going to combine these into one demo, the CM Monitor solution, and this is a name that we came up with. One, I like the CM part because it sorts with the Configuration Manager databases, so hopefully somebody else doesn't look at it and go, we don't need this, and delete it, right? And hopefully if you've done the right thing and revoked the built-in administrators group, you should have a narrow subset of people that actually have the ability to do that. So what does it do? What it does is I went out, I have to say, I looked at probably 6 or 8 different solutions out there publicly available, and I also thought about writing my own custom solution. And I have a lot of scripts to do these reorganizations and kind of intelligent looking at how do I reorganize statistics, how do I rebuild indexes. And I came across this one, which it turns out it's okay for me to say it? Our friends at Wells Fargo also use this same script, and I've used it successfully at Dell, again, managing a large number of clients. And we found out in today's session that Microsoft is also using it. So I think that's kind of cool that we picked something that's, I think, not only well-built, but it's very intelligent. And what it does is and the way I've implemented it and the way I'm going to show you, I had a couple of design goals in mind. One, I wanted to make it easy to use, easy to implement. We have technicians in our group that will basically implement these. So I had to make it kind of turnkey, right? Just run it 1, 2, 3, and you're pretty much done. And so the second one is I wanted to be intelligent enough so that it could figure out the fragmentation factors, tell me what I need to do in order to fix things. And then secondarily to that, I wanted to make sure that it didn't introduce any changes to the Configuration Manager database. I didn't want to get into a point or a situation where Microsoft come back to, hey, that's not supported, right? So it's kind of a solution you can just drop in. And then the other thing that's really kind of cool about this is it gives us the ability to actually monitor what's happening in the background. So when these tasks run, it actually logs it to a table. I can go in and look at it later or run reports from it. And I've got a link here as well. So what are the steps involved? Actually 3 steps. Create the database, we create the objects in the database, and then we set up a scheduled agent task to run it and whatever parameter you want. And I'll tell you how I've done it. But I mean, feel free to experiment, and I heard today, we'll get to that in a second, but Microsoft is running it weekly and then updating statistics nightly. I tend to run it once a week, and I'll explain why in a few minutes. Give me a second to load my files here. as I said, I'll make all of these scripts available. And the first thing I wanted, and actually I wanted to circle back and show you something else, which is good to know. And this goes back to, how do we determine whether or not our statistics are up to date? How do we know about indexes? And again, I will provide these. And this one uses our system dynamic, or DMVs, dynamic management views, to pull information, the stats one that I told you about earlier. It gives us the ability, so if I run this, and I've already run it once on this machine, so it's going to run pretty quickly. Statistics one runs pretty quickly, even on a large database. And notice there's a lot of information here. It tells us whether or not the actual table names, it gives us a stat name, and you can pretty much tell once you start getting used to this, the ones that are auto-created. The other ones that are auto-created have the underscore like WA and the sys in there. And they're also, I believe it's a type 1 for auto-created. It also tells us when was the last time these statistics are updated. And this is probably the information I'm going to be most interested in. And what I like to do is just kind of scroll through this. Not real scientific, I know. But I like to scroll through it and just see how do things look here, right? I mean, in this case, these statistics look pretty good. They're not too bad at all. And it just so happens that I uploaded this database not too long ago, so the statistics are pretty fresh. But I have to tell you, I've seen some databases where these will be really old. Okay, so if you see like really old dates here, it's an indicator that these statistics are probably pretty horrible. So the next script I want to show you, and these are also included in the PowerShell commandlet, is the fragmentation. And this is an interesting one to kind of, let's walk through it. We're using the DMV, the DB index physical stats. So this gives us the actual physical statistics. Notice I'm culling out, I'm only showing page counts that are over 1,500 because I really don't care about the little ones. And then finally, what I'm going to do is pull out just the key pieces of information here. And again, this could take a long time to run on a large database, so just be patient and let it run. So it gives me a lot more information. Notice my average fragmentation in percent, and I've also ordered by in descending order, so I'll see the most fragmented at the top. It gives me my page count, shows me the fragmentation count, and I can tell by looking at this database is not fragmented at all, and that's probably because I did a restore here. So let's go look at implementing the solution now. As I've gone through, I like scripting a lot, and just because it makes it easier to reproduce. And the first one I'm going to show you is creating the actual database itself. And this is, again, the database CM monitor. The thing you'd have to configure are really the first two rows here, depending on where you put it. Obviously, I'm running a laptop. I don't have multiple drives on this device. But likely, you'd change the drive configuration to point to whatever drive is standard for your database and for your log file. It doesn't have to be very large either. I think I've got this set to 10 megabytes. I mean, you could set it a little bit larger. However, it's fine for the kind of work that we're doing here. And the other thing by scripting is it'll keep all the settings that I had before. To show you how to generate one of these just before I run it, and I apologize for jumping around just a little bit, but you might find this useful. If I wanted to duplicate, let's say, this database, perfdb, I right mouse click, I click tasks, and then it gives me the ability to let's see, script database, next line up. I can drop and create to clipboard or a new query window. Let's just go to a new query window. That's what happens when I do an unscripted demo, right? And it will give me a full basically script to recreate that database. So I can recreate that database on another server. So once I have jumping back to CM monitor, and that's how this script was created, by the way, I can execute this, and it shows it was created successfully. Let's go back to our databases node, do a refresh, and you'll see that CM monitor is there. Now let's take a look at it. I want to make sure that our recovery mode is set correctly. And a couple other things I would like to point out here. One of the things that I like to change fairly early on is in the file section, change it from the owner to something like SA, so there's no issues there with, let's say, either permissions or whatever. Make the owner SA. The other change I like to make, if it's not already set, but because I scripted it, is notice our recovery mode. should be set to simple, because I don't want the transaction log file growing. There's no reason to have it set that way. And in fact, for a configuration manager or reporting server, you should just leave it set to simple mode. The next phase, I've got my database created. I took the script that I showed you before, and I've just simply named it Maintenance Solution, Custom. Because what I've done is, by default, Ola's script writes all this information to the master database. And I don't recommend that. You really shouldn't be using the master. So what I do is change it to use CM Monitor, which is the newly created database. And then I've also gone through and I've tuned a couple of things, because this maintenance task, and it's all documented here, will not only create maintenance tasks for your index and statistics updates, but it'll also handle consistency checks, and it will handle other integrity checks. So I run this thing. And it shows it's completed successfully. Go back in and take a look at CM Monitor again. And there should be one table here, command log. And the command log is where information gets written if I tell it to log to a table. So this gives me my history now. And then the final step is I'm going to create an agent task here, which I exported from another device. And if you look at the script here, what this does is this gives me a name, and I call it Index Optimize and MMS 2013. I'm just going to run this, and then we'll go in and take a look at the agent task. And the SQL Server agent, of course, has to be running. And there's our new Index Optimize. We open this up, and you'll see I'm going to jump down to schedule. You see I've got a schedule already set, and I recommend running it after hours. Weekends are fine, but make sure that you're not running a backup against your database at the same time this is running, because it can be resource intensive. On our large database, which is probably approaching 700-800 gigabytes, the first time I ran it, it took almost 12 hours to complete. But the nice thing about this script is because it is intelligent, once it runs and reorganizes everything, the next time it runs, it doesn't have to work as hard, because things are not as not out of compliance as before. So I'm running this once a week, and I've picked Monday at 6 p.m. because that's a fairly quiet time for us, and it's not in the middle of the backup cycles. The other thing I'm going to show you is actually on the step. Defragment indexes is the name of this, and if I open this up into edit mode, there we go. And let me zoom in on this. Okay, notice that a couple of things. I've got the name of my database defined here. One of the things I really, really like about this script is I would also recommend adding susdb to it as well, and any other databases that get often updated. In fact, I found some performance even with the weekly scheduling, the syncs out to the cloud and bring back to susdb. So you can add other databases to this, which makes it not only highly configurable, but something that you can do beyond what the site maintenance task will give you. Okay. The second thing that is interesting is I can set fragmentation levels here. By default, it was 10, and this defines what is considered a moderately or lightly fragmented index. In other words, anything over 10, I'm going to do reorganization. And the level 2 is anything that's highly fragmented, which means I'm going to do a rebuild. Now, this by default, it was set to 10 and 30. So I set it up just a little bit because I didn't want it like hammering it too much. It's like in some cases, making it too efficient is going to take even longer to run. So you can consider adjusting these up or down depending on your situation. And the other thing it will do is, in fact, only modified statistics set to Y. Log to table, you have to turn this on. That's why I have this script, and I'll include it. You have to turn this on in order to log it to the command log table I showed you earlier. And the other feature that I put in here, and notice the two little hyphens in front means it's remarked, but I've been experimenting with this one, sort and tempdb. What that allows you to do is, if you've got sufficient capacity, is as it's sorting the indexes, it will actually use tempdb. And I found that when I enabled this on a very large database, it saved an hour in terms of the total reorganization time. So it might be something to look at. Now, I'm not going to run this now because, frankly, we're almost out of time. But what I will show you is I restored a copy from our production database, one of our sites, and this is the site that has about 70,000 clients, and that's the CM Monitor AME database. And I just wanted to show you, in fact, I'll select the top 1,000 rows. And this is the information that's being logged to this table every time that this task runs. What's kind of interesting is it shows exactly what it's doing. In fact, you can see all of the activity just on this first table here. Let's scroll down to something else. Perhaps assignment status. And you can see if we scroll over to the right here, let's just pick one of these, it shows us that, in fact, it's updating, altering the index. What's nice about this is I can copy this and then paste it up here, or Notepad. And I can see exactly what it's doing, So that I find that incredibly useful. And if I couldn't tell it was actually an alter index, it tells me what the command type is. And then it shows the start time and end time. So you can start taking a look at, okay, how long do each of these tasks run? And then secondarily, taking that one row, which is kind of neat, is on this extended info. It puts a little XML tag. It shows me the page count and the fragmentation level that was there at the time that it actually launched this. So it gives us quite a bit of information. And then also you'll see that it clearly tells us where it's updating statistics. Now, the reason I mentioned that I like running this once a week, but again, experiment with it, tell me what you think. I'd like to hear from you on that. Be cautious, though, with the updating statistics, in that every time you update the statistics, it causes the queries to recompile. So you could lose some efficiency by always updating your statistics. In other words, it's too much of a good thing. You know what I mean? So to kind of wrap things up, I went through a few query scenarios. I like to start off with kind of like what I think is sort of close to the solution and then refine the queries. It's sort of an iterative build process until I get what I'm looking for. Understand that as you start running into performance and issues within queries, to understand how the queries actually function in SQL Server, I think will help you figure out what side of the equation. And the other thing is that might be interesting, and I've always wanted to go back and do this, but normally I just go update statistics, update the indexes, and then statistics would be the right order. However, sometimes it might be interesting to just see if statistics are really out of date, maybe just update those first and see if you get an improvement. The SQL audit implementation is, again, a way to document, identify, and remediate. It gives you that information you need to fix things. CM Monitor, again, hopefully self-explanatory. There's a lot more documentation on our OLA's site which explain other methods of using it and other parameters. And then finally, report back. Let me know what you think, if it's working properly for you. I think we've got a few minutes left for questions. Feel free to use the mics, come up here. And then also I wanted to call out Brian and Kent's session. And I mentioned my blog is also my email. If you have any follow-up questions from the session, more than happy to help you out. And I also recommend downloading, take a look at the slide decks from today's session, SQL Top 10 Lessons Learned in Managing SQL and Reporting. And that's where the Microsoft folks actually called out OLA's solution. So with that, thank you very much for joining me.